In this lesson we want to find out how to use subqueries as a filter condition. What is a subquery, first of all? A subquery is a second query you build into your main query. So the subquery is just as much, in most cases, a valid query in its own right, but it contributes some aspect to your main query. For example, it creates a dynamic value in a where clause. And that is exactly one of the typical scenarios where you use subqueries. So, for example, if we look at our select star from person again, which we see here, the output of that table, we could, for example, say we want to, out of that table, we would want to see the person, the oldest person or the youngest person. Now, there's no way we can do that in one query. We can, of course, do something like a max date of birth, and of course that will give us the youngest person in the system. But of course, as we've said before, we can't combine that with outputting other details about that person. If we want to do that, we need to build this max thing as a subquery in there. So what we're going to do is we're going to stick another query around that then allows us to output the details about that information. So that would go back to our select star from person, where, and now of course we would need to look what we want to do. We want to basically get the person, or strictly spoken the persons, with the maximum date of birth, so the youngest persons. Of course, because we work set-based in SQL, in theory we could have more than one person on the same birthday. Which is another hint why these kind of queries just don't work in one go, because mentally we may think we're looking for one record, but actually if we think about it carefully we will find out it's more than one record. So what we're going to do is we're going to stick in a filter which checks on the date of birth being equal to that maximum date of birth we distill in our subquery. And again, though not necessarily required, but good practice is to just put a pair of brackets around it. That way you are sure that you know what you get. Now again, we can test this quite nicely in components. We've already done the max, so that is the 1990 birthday. So now we can go by and just execute that line and can see who that is. 1990, that is Jenny Palmer, we expect that. So we actually only have one hit here. But of course we could have more. Now then we can run the full query, and there we go. So there we have our youngest team member basically put out with that query. And these kind of scenarios are a very common example for subqueries, where you dynamically need to create a where clause, and you need a value in your where clause which is not directly in your underlying table you're querying, but is distilled from something else. I could do a similar thing now and, for example, say I want to see all those people that are younger or older than the average. So I could change that in an average. And obviously the equal wouldn't create anything, because the chances that we have one person which sits exactly on the average is highly unlikely. But of course we could say we're looking for those younger, so their date of birth would be after the average. And now we can run that again, and you see there we get two people. if we want to be sure that we done the right thing, of course we can test the subquery. But also I'm going to do the other way around now first. So we're going to do the guys older than the average. So we have 2 under the average. So because we have 6 people in there, we would assume that we find some 4 on the other side of the query. We're actually only getting 3 because actually if we look back into the first, we find there is one that doesn't have a date of birth. So that makes sense. Yeah? So again, that strategy makes sure that you test these things properly. So I'm going to take that subquery out here and run that individually just to be sure that that does what I want. And you see that of course gives some funny number. One of the tricks you can do is you can stick that in a date and that converts it into a proper date. And you see then we get our average date. So the average date of all the birthdays we have in there is the 14th of July 75. Yeah, and always remember to do these tests. Don't trust yourself, don't trust your own cleverness. I can tell you how often I've hit the wall with that. So better safe than sorry. Test the components in such a subquery. So in this kind of scenario, of course, you can use in all kind of operations. Obviously in that subquery you can put whatever you want. So everything we've learned so far in our other lessons about the select query you can use there. And of course it can come from different tables and so on, as long as the output matches. So on this occasion where we do such a kind of equal, smaller, larger comparison, you need to make sure that your subquery creates exactly one value. That's also known as a scalar subquery. So if this one, for example, wouldn't be an average, for example, you would just say I select the date of birth, yeah, which basically creates you a 1-column table of dates of birth, then this query shouldn't work. Again, you find some database systems being a bit more tolerant these days, but the same as elsewhere, this tolerance normally goes wrong. So if I do this, you see the query actually gets stuck. So it's an invalid query. So it's important to always look out for this scenario where you build subqueries that the data types you work with are fitting. So if you need a scalar value, you need to have a scalar subquery. And in the end, you also need to make sure that, of course, the kind of data, the data type, whether it's a date, whether it's a string, whether it's a number, are fitting. Else you're going to get all kind of interesting effects, because in certain areas the database may just convert things, but the chances are it doesn't actually convert as you would like to. Right, so that is our first variation. The second variation is to exactly drill that idea further, that you may actually have a non-scalar subquery, and that's where your in clause comes in. We've mentioned before. Now the in clause allows you to actually check against a list, and for example we could say we want to check the ID. So we want to filter on a sublist of IDs which typically will come from another table. And that is where the in clause becomes interesting. Of course you find in clauses where you have a hard-coded list, but that normally points to maybe your database design not being quite as great as you wanted. Now we want to create a subquery here which is dynamic, and I'm going to have a quick look over on our diagram. So we're on the person table, and you see in the project person table we have, for example, the role, and now we could go by and say we want to have all those persons in the person table that actually fulfill a certain role in whatever project, which is that RID. So I give us a quick insight here into that role table. Select star from role. And there we go, we have 4 roles. And equally then we can have a quick sneak peek on the other table we're gonna use actually, which is the project person. So, and there you see we have various people in the different roles, so we can almost pick whatever one we like and that way build our subquery, which we're going to do here now. Again, if you can, build your subquery beforehand to make sure it creates the right data. So we've said we want to filter on a certain row ID, so where RID equals, and let's say we take 4. Now if we run that, you see we return 3 people, and here we have the person ID, which is our primary key in person. So we have 2, 3 and 4 returned. So now I can copy paste that thingy in here, and the kind of structural bit is relatively up to you. I sometimes do it this way, sometimes do it that way, and quite often I just tend to indent that subquery. SQL doesn't mind that at all. It's of no relevance how you indent things like that. But now you see we have here our select star from person, where we filter on the ID in person to be in this list that this subquery returns. Now if you try that, you will again find that won't work yet. It crashes. Why does it crash? Because we are checking on the primary key, on the ID in this list, but our subquery actually returns a table, not a single column. The in needs to have a single column table. So obviously we need to reduce that here to PID. So we only want to have that column where the person IDs for those person in that table with the role 4 are in. And then we can run that against here. And you see now we get our 2, 3, 4. And you see also, interestingly, the order of these records of course gets determined by the main query, unless we do a specific ordering. So the subquery just creates that list as a filter condition for your query. Right, so there you have your subqueries used to filter. Of course you can spin these ideas on in a whole range of different ways, but these two are really the most commonly one, the Scala subquery and the single column subquery that feeds into an end clause. By the way, when you look at this last example, you may rightly say, is that not something we could do with a join? And you're absolutely right, we could, but we're going to look at that comparison between subqueries and joins at a separate lesson.